In Unit 7, we're going to study something called significance testing. Now, a significance test is the process that you would use to test some sort of hypothesis. So basically, if you've ever wondered, you've seen a radar sign on the side of the highway and you wonder, does that radar sign really make people drive slower? Or maybe you've wondered if posting an employees must wash their hands sign in the bathroom makes all people more likely to wash their hands. Anything that you've ever wondered, you can test with some sort of significance test. And it all is going to start with a hypothesis. So that's what we're going to practice first, is we're going to practice writing our hypothesis. Now, when you write a hypothesis for a significance test, there's two hypotheses that you're going to write. The first one is called the null hypothesis. That's this symbol here, HO, the null hypothesis. This is just your original claim. This is what is previously known or thought to be true. It's always kind of your control, that there is no effect. This is kind of your basis or your foundation. And then your alternative hypothesis, your HA, your alternative hypothesis is whatever it is that you're trying to prove. So let's take a look at a few examples. Last year, the average SAT score of students attending UT Austin was 1350. Has the average SAT score of students attending UT Austin increased this year? So null hypothesis is whatever was previously known or thought to be true. So it says last year the average SAT score was 1350. This is what was previously known to be true. So our null hypothesis is going to be that the mean for this year is the same as it was for last year. We're going to assume that there was no change. But we are wondering if maybe it has increased this year. So our alternative hypothesis, our HA, that we're trying to prove is that the mean for this year is greater than it used to be. So greater than 1350. Now keep in mind that the symbol mu here represents the mean. It represents the mean SAT score for this year. So either that mean for this year is the same as it used to be, or we're trying to prove that it's greater than it used to be. Another example, after surgery, patients are asked to rate their pain on a scale of 1 to 10. With the old pain medication, the average pain level of patients after surgery was 6.8. A new pain medication has been developed that's thought to reduce the pain after surgery. All right, we want to do the null and alternative hypothesis here. So remember, your null hypothesis is the original claim. It was what was previously known or thought to be true. Well, we know the old medicine was 6.8. So we're going to start by assuming that the new medication is no different. We're going to assume that the new medication is equally as effective as the old medication. So our null hypothesis is that the mean for this medication is 6.8, just like the old medicine. But we hope to prove that it actually reduces the pain after surgery. Reduce means decrease. So we're trying to prove here that the mean is now less than 6.8. And again, that mean represents the mean pain relief with the new medication. Last one of these. According to data from the Social Security Administration, the raw average salary was $39,959.30 back in 2011. State the null and alternative hypothesis that can be used to determine whether the mean annual salary has changed since 2011. All right, so our null hypothesis is our original claim, whatever was previously known or thought to be true. Well, back in 2011, we know that the average salary was $39,959.30. So our null hypothesis is that the mean now is the same as what it used to be. But we're trying to see if it has changed. We're not specifically trying to prove that it's gone down. We're not specifically trying to prove that it's gone up. We are just trying to prove that it is different than it used to be. So here we're trying to prove that the mean now is not equal to $39,959.30. And again, the mean represents the current mean annual salary. So we're assuming that the mean today is the same as it was in 2011, but we have reason to believe that maybe it's changed, so we're trying to prove that it is different.